In this video, we're going to talk about Google DeepMind, which has introduced Gemini Robotics on-device robot that basically doesn't need the cloud or internet access. It runs 100% locally, and that completely changes the game. We'll discuss all of this in today's video, but first, leave a comment below. If money were no object and you could buy a robot, what would you use it for? Would it be for your factory, your business? Would it be as a companion? Would it be as a robot girlfriend? Would it be as a friend? Would it be to wash your clothes, take care of your house, look after your child? Anyway, if you had a robot, what would you use it for? Leave your comment below. Let's go straight to my computer screen. Let's react to this video called Google has just launched an autonomous robotic brain. Let's take a look here. Let's comment. I also ask for your help in the comments. Let's talk. 3, 2, 1, go.
Google DeepMind has done something that could forever change the way robots work. Carolina Parada and her team have unveiled Gemini Robotics on Device, a simplified and supercharged version of Gemini 2.0 that doesn't need the cloud, Wi-Fi, or even a whisper of internet to work. This thing runs directly on the robot, which means there are no delays, interruptions, or waiting for a server on the other side of the planet to figure out what to do next. Just real-time thought and action, right there on the factory floor, in your home, or even out in outer space. It's like cutting the leash and giving robots their own brain. One that's fast, adaptable, and always ready. Now, since this model works offline, efficiency is everything. DeepMind engineers optimize the architecture for the dual-arm Aloha equipment used in training. However, it still handles vision transformers, language encoders, and action decoders all in one neat package. We're talking about inference that fits on the kind of embedded GPU boards you'd put inside a mobile manipulator, not in a server rack. The result.
Well, let's get to it. The first issue is that to run it locally, you're going to need a heck of a processor, right? Of course, they're getting smaller and more optimized all the time, but they still have to be extremely powerful. Apple, for example, boasts that everything happens right on the iPhone, right? You don't share your data there with other servers. You don't send documents or commands to other companies. What you gain from this is privacy, right? Because if everything runs on your device, in this case, everything will run on the robot then. You won't need to share sensitive data, and that's really good for privacy. Now, I'm absolutely sure that at certain times you'll need to connect to the internet to do updates, I imagine, right? But let's keep going here.
The fact is that the robot's control loop remains well below traditional latency limits, tens of milliseconds instead of hundreds. So, when a sudden change in the object's position is detected, the sensor allows the planner to react before momentum carries it to an undesired location. The performance numbers confirm this. DeepMind published side-by-side charts comparing the device with the same flagship hybrid and with what used to be the best purely local VLA. The device practically hugs the hybrid curve in visual, semantic, and behavioral generalization tests, and far outperforms the previous on-device champion, especially when you throw invisible objects or strange lighting at it in benchmarks.
Basically, what he's saying is that since it's not connected to the internet, you also gain in terms of speed, right? Low latency.
And following instructions, multi-step tasks with lots of natural language nuances. It also closes most of the gap. That's amazing because the hybrid model still has a direct fiber line to those huge TPU pods. And yet the little brother hanging on an edge box is almost keeping up. Alright. Real-world tasks ready to use. The demo video shows the robot opening soft lunchboxes, folding shirts with real creases, pouring salad dressing into a narrow container without splashing, and even sliding a cart out of a deck. Small details, but a nightmare to program manually. It does all this after seeing maybe 50-100 examples.
Well, I'll go ahead and give my opinion. I would definitely have a robot like that for household chores. I want to wake up and have it already making my coffee, already preparing my scrambled eggs. Then suddenly it's already vacuuming and cleaning the bathroom. Clothes always clean and folded, so I would use it for household tasks. Of course, also cooking, washing dishes, in short. A multifunctional household robot, that's what I would use it for. Comment below what you would use it for. I would easily trade a car for that.
The session count is important. Data collection is expensive, whether you're in a simulation like Mujako or on real hardware with a human operator demonstrating the movements. Reducing fine-tuning to just 2 digits removes the barrier for researchers who don't have thousands of hours of teleoperation footage available. Alright. Now, remember when self-driving cars seemed like science fiction back in 2019? Now, more than 400,000 Teslas drive themselves every day. And while
Well, sort of, right? It's not 100% autonomous. And I recently made a video about robotaxis. I did one about the launch and another about the problems that are happening, like accidents and so on. When you finish this video, look, I'll leave this other video here for you to watch. Okay?
While no one was paying attention, AI adoption exploded by 270% in just 3 years. Antiseptic companies are now 15% more productive than their competitors.
Just a reminder, folks, we've opened our members club here on the channel. Basically, here's how it works. Level 1 members will get early access to videos, and I'll reply to your comments with priority. Now, at level 2, in addition to all that, you'll get exclusive videos and you'll be able to make a post in our community with a photo, and you can ask me anything you want about business, recommendations for AIs, what I'm doing to make money, anything you want my opinion on. If you're a level 2 member and make a post with a photo, I'll reply there with priority. All right?
McKinsey predicts that AI will add $13 trillion to the global economy by 2030, but it will also force 375 million people to change careers, and these roles will require serious AI skills. Google, speaking of demonstrations, trained only on device on its internal platform, Aloha. But then they ported exactly the same weights to a Franca FR3 barn workstation and to the Aptronics Apollo humanoid, without retraining from scratch, just a short adaptation run, and the model suddenly understood the different joint kinematics. On the Franca, they performed sequences like assembling a belt, aligning pulleys, and tensioning a belt, as well as folding a long summer dress without stretching the fabric. On the Apollo humanoid, which is much taller and has completely different limb proportions, the model still followed spoken instructions, manipulated random household items it had never seen before, and put a Rubik's Cube into a bag as if it had been practicing that body trick all week. We are creating libraries of skills that are independent of physical form. Trained once, transplant almost anywhere. Developers who want to dig into the guts can sign up for the Gemini Robotics SDK, which comes with interface code for live robots as well as complete simulation scenes from Model Company.
The big question is the price, right? It's the price we're just at the beginning still developing. There are already many robots in factories, but now bringing them into your home, there are some challenges. First, the price. Second, the fact that it's still not that advanced yet, right? It's making progress so that it can have the ability to pick things up like this, right? To have that skill to pick up eggs, for example, which break easily, or to pick up glass, for instance, with ease. And when we get to that point, which is already happeners, the issue that every home is different. The size varies, the layout varies, the number of people varies. The kitchen design is different. Sometimes it's small, sometimes it's big. The appliances are different, so the robot will have to deal with all these challenges, right? Because unlike a factory, which is kind of rectangular and basically always the same, you train there. How are you going to sell a model when there are 500 million, a billion different homes? How is the robot going to adapt? Would it be something like, like a vacuum cleaner? It goes around scanning or mapping everything. The robot will have to have something like that. Let's keep going here.
Model Co's physics is fast enough to generate contact-rich demonstrations on a laptop, so you can gather those 50 demonstration datasets in virtual kitchens or mini factories before even touching the physical robot. Next, you do the fine-tuning locally, because yes, this is the first Google VLA where fine-tuning is officially supported, and you send the updated weights directly to your bot's flash storage. Early access is available through a trusted tester program. They're still not opening the floodgates, partly because of safety reviews. In this regard, DeepMind continues to echo its AI principles. Be helpful, don't be reckless. All those good things. The company connects semantic filters. Prada herself told The Verge that everyone was surprised by the strength of the on-device model. She called it an initial model, but it's already approaching production level when connectivity is unstable or data sovereignty rules prohibit cloud calls. Think of robust warehouse corridors where the Wi-Fi dies behind rows of steel racks, or defense companies that keep everything on site for obvious reasons. Zooming out, this gives a push toward robots acting in real time on factory floors, distribution centers, or offshore platforms where cables are a luxury. If you have a pick-and-place task that occasionally changes when pallets arrive late, a low-latency, adaptable controller that learns new packaging SKUs in an afternoon can greatly reduce downtime. It also lowers the cost of ownership. with no recurring cloud computing fees, fewer security audits for data output, and the ability to update the same model across different mechanical platforms you already operate.
Basically, what he's talking about here, as I already mentioned, is that since you don't need the robot to be connected to the internet all the time and you don't need the cloud whenever you're somewhere in the warehouse or at home and for some reason the internet goes down, the robot won't become unusable, right? And besides that, the responses are also faster because you don't need to like give a command, have it connect to the internet, access some database and then respond. Maybe their server is slow, maybe your internet is slow. So with this model, with this technology, that's definitely going to be solved and will keep getting better and better. Comment below then if you had a robot, what would you use it for? And just a reminder, I'll leave the next videos here with recommendations for robots, for those of you who like artificial intelligence and robotics. See you in the next video. See you soon.